Okay, go. Alright, wait, so electrochem is where we have redox reactions, and redox reactions do what?
They redox.
That's the oil rig, so they're doing what? Oxidation and reduction, they're transferring electrons, right? So redox reactions transfer electrons. So you have two types of electrochemical cells. The first one is a galvanic cell. Galvanic cells are thermodynamically favorable, so delta G is negative. And if delta G is negative, what is your E cell? Positive or negative? Positive, and K is greater or less than 1? Thermodynamically favorable, K is greater than 1. All right. So, like someone said, oil rig, oxidation is losing electrons. If I lose electrons, what happens to my charge? Does it go up or does it go down? Charge increases. That makes sense to you guys? So, oxidation would be copper solid going to copper 2+. That's an example of oxidation. For my half reactions, where do I write my electrons for oxidation? So first of all, how many electrons are transferred here? 2, all right. So where do I need to write them? If you ever can't remember, we've got to balance my charges on both sides. So this is 0, this is +2, so 2 electrons has to go on my product side. So these are your half reactions. Okay, reduction is gaining electrons. And what happens to my charge there? It decreases. And so an example here, let's just write the same equation backwards. So Cu2 plus goes to Cu. And so to balance my charges, I have to put my 2 electrons on this side. That would be what we call a half reaction. Is that her? Are you whistling? Are you whistling?
No.
Who's whistling?
That's Albert.
Albert?
Stuff's gonna start flying off the wall.
Okay. Okay. So, what are you saying? So, oxidation. This is your galvanic cell. Remember, galvanic cells have a salt bridge. And a salt bride. Salt bridge. And it has 2 electrodes. It has 2 containers. What are the electrodes called? Anode and cathode, right? So your anode.
Please write that smaller.
Is where what occurs?
Oxidation.
Oxidation. And your cathode is where reduction. Okay? What happens to your anode over time?
It gets smaller.
Gets smaller, right? So it loses mass. I'm not meaning to that time. What happens to your cathode? Gains. It's pretty appropriate, huh? Okay. Now, how do we remember these? Alright, so anorexic, ox, and fat, red cat.
I think that's
Okay. So now, how do we know? All right, so I'm going to give you an example. We have iron 2 plus 2 electrons goes to iron solid, and that has an E cell of negative 0.44 volts. And we have silver plus 1 electron goes to silver solid, and that has an E cell value of 0.8 volts. How do we know which one is reduced by just looking at this?
The more positive one is reduced.
Very good. The more positive, very important, more positive E cell is always reduced. So, let's fill out our galvanic cell, okay? Let's call this one the anode. Actually, no. Let's call this one the cathode. And let's call this one the anode. Okay, so which one of these metals, iron or silver, is going to be the anode? Iron. So Fe is going to be right here. And that means that the cathode is going to be Ag, silver. How do electrons flow? Very good. Y'all do remember this. Electrons flow, alphabetical order, anode to cathode. So if I want to show my electron flow here, it would be this way. If I have in my salt bridge KNO3, which way is each going to go and why? What is it, Rose? Which one's going to go to the anode? Which?
All gonna go that way.
Alright, so when I have a salt bridge, these split up into ions, right?
Yeah.
So it splits up in K plus and NO3 minus. Which one's going to go to which side? Okay. Anions go to the anode. Cations go to the cathode. And I'm going to explain why. Okay, so this is for my salt bridge. Salt bridge, that's what happens. So in this case, my anions are going to go to my anode. So NO3 minus is going to travel in this direction. My K plus is going to travel in that direction. And what's the purpose of the salt bridge? It balances out the charges. Now, here is conceptually why this is the case. My anode is losing mass, right? So this little thing is losing mass, losing mass, losing mass, losing mass. The reason why is because I'm getting more Fe2 plus, another Fe2 plus, another Fe2 plus, another Fe2 plus. What's happening to the solution? Is it getting more positive or less positive? More positive, because I have more positives jumping in, right? Because you will always have some sort of spectator in here. So you'll have like nitrates or something in here. So I have more positives than I do negatives. So this is getting more positive, So I have to have this negative to balance that out. Okay? What's happening over here is that this one is gaining mass. So I have, there you go. Okay. I have AGs jumping onto this, gaining mass, gaining mass, gaining mass, gaining mass. To do that, I have a bunch of AG pluses in here that are jumping on. So when they're jumping on, they're no longer there. When it jumps on, it's no longer there. There's my NO3 spectator there. When another one jumps on, it's no longer there. So what's happening to that solution over time? It's getting more negative, right? So if this one's getting more negative, then I have to have this positive potassium to come and balance that out, or else my electrons are going to be staying here, because if this is getting more positive, my electrons are going to be attracted to this solution. They're not going to want to go to this side, okay? So that is conceptually why your anions go to your anode and your cations go to your cathode, okay? And remember that a salt bridge, what that does is it balances your charges in the solution. All right, that's the purpose of it. If you immediately take your salt bridge out, what happens to your E cell value? Becomes 0 immediately. Right. All right. How do we find this voltage? What we call this is standard E cell value. And a lot of you guys ask me this question. What does that little symbol mean? Standard conditions, right? Standard conditions. And what is standard conditions? What degrees Celsius? 25 degrees Celsius. And it's still 1 atm and all that good stuff. It is not 0 degrees Celsius. It's 25 degrees Celsius for standard conditions. STP, standard temperature pressure, that's your 0 degrees Celsius. These are two different things. Standard conditions is what we do in lab. STP would be extremely cold if we were doing it in here in lab. Okay? 0 degrees Celsius. All right. So how do we find that value? Do what? Okay, so we got to flip the sign of one off. And which one do we flip the sign of? Oxidize. So to find this, we flip the oxidized sign. Okay? And then we add them together. And flip the oxidized sign and add E cell values. That's how we find this. So what I would do, so I flip oxidized, so it's positive 0.44 plus 0.8, and what would that give me? 1.2, is that right? 1.24 volts, and that would be my E cell at standard conditions. If I have standard conditions, what is the molarity? 1 molar. All right, so standard conditions, 25 degrees Celsius, 1 atm, and also 1 molar. If I do not have standard conditions, first period definitely should get this because it's their favorite. What do we have to do? Nernst, right, very good. So, Nernst is this equation. Is non-standard conditions. Okay, so that is your E cell, this is at non-standard conditions, is equal to E naught cell, you see how this is standard conditions, minus 0.06 over N times the log of Q. Do what? That's a good question. I don't think it is because they give it to you now, or what they're basically asking with NERTs is Le Chatelier. Okay? So you could have that equation. So this is where they'll primarily ask you, it'll be conceptually, where you have, what was it? Was Ag reduced? Ag was reduced, right? And what else do we have? Iron. Okay, so, and then you have to balance. Y'all remember how to write these reactions? Okay. All right, let me go over that. So, when I write these reactions, I have to show that whoever's reduced is going down in charge, right? I have to show whoever's oxidized is going up in charge. Then I draw my electron bridge. Y'all remember that? Maybe? Okay, so Ag plus going to Ag, how many electrons is that transferred? 1 electron. Fe going to Fe2 plus, how many electrons? 2. So I have to balance these electrons, right? How many electrons should I have on both sides to make them even? 2. So to make 2 on both sides, I have to do what? Multiply this one by 2. And I multiply everything that's attached to that by 2. So now that's my balanced equation. What was I getting with after this? Conceptual NERDs. Okay, thank you. All right. So close. Oh. So what if I increased my Fe2 plus? What will happen to my E cell? Well, we know my reaction is going to shift in this direction, right?
So it will decrease.
It will decrease my E cell. If my reaction shifts in this direction, E cell decreases. So, reaction shift, E cell decreases. If my reaction shifts in that direction towards the products, my E cell increases. And that's the conceptual component of the Nernst equation. Yes.
So, how many, what would your total moles of electrons transferred be?
A very good question. My total moles of electrons would be whatever's balanced on that bridge. Okay? So you see how we had 2 on both sides? 2 would be my total number of moles. So it's whatever that common number is between them. All right? And that goes into delta G equals negative Nph. This is your total moles of electrons. All right? And so like Eli was just asking, how do I know what that number is? It's whatever that common number is between your moles on both sides. Right? It's not them added together. It's not them multiplied together. So an example is, if I have aluminum plus 3 plus iron 2, iron goes to iron 2 plus aluminum. First of all, what is my balanced equation? Let's draw our electron bridge. So we have 3 electrons here. We have 2 electrons here, right? Now those are not balanced, right? So what do we have to do to balance them?
Multiply by 2.
Multiply by 2 and multiply by 3. So what would I plug in right here? 6, exactly. Okay, so don't forget how to do that. Why is it 6? It's because that's how many total I have. So when you're looking for N, look at one of your lines figure out those total moles from there. Don't add these together or anything like that. The reason why is because 6 moles are being oxidized, so it's losing 6 moles of electrons and giving it directly to whoever's reduced, whoever's gaining. So there's just a total of 6 moles. It's not 6 electrons, let's grab and take however many we need. It's 6 electrons being lost and giving it to the other species that's being reduced. That's why, 6. All right, negative infinity, we know what F is. Faraday's constant, which is what number? 96,500. Very good. And then E cell, this is, I should label it a little bit better. E cell. So this is at standard conditions there. So you would do this to find its value. All right, we also need to talk about electrolytic. Here's the main thing that they ask with electrolytic. No, we got electrolytics. Okay, electrolytic cells are thermodynamically unfavorable. So what that means is that delta G is positive, E cell is negative, and K is less than 1. You still have anode as where oxidation occurs. You still have your cathode where reduction occurs. And you still have electron flow going from anode to cathode. The only difference here is that you do not have to have a salt bridge. You usually have both of these. And you have to have a power source. So what should be here instead of a voltmeter, it should be a battery. So this needs a battery. A power source of some sort. It needs a power source to work. But you do not have to have a salt bridge there. Finding your E cell, you do the same thing. Okay? Here's the biggest thing that they ask you questions from for the electrolytic cells. It's known as like metal plating. Okay? Metal plating is the big concept they ask with this. So this is where you use the equation Q equals IT. And with the plating, they ask either how long, so they're looking for time, or they ask how much. So when they ask that, they're looking for grams. Q here is not the same as Q in thermo. Q here stands for charge, and it is in coulombs. I is current, and it is measured in amps. And T is time, and that time has to be in seconds to combine with the correct units.
What's the I?
Current, and it's measured in amps.
What's Q?
Q is charge, and it's measured in coulombs. So, let's say that we have copper that we're plating. So we have copper 2 plus solution in here, and we're trying to plate copper. So copper 2 plus is going to copper solid. And we want to know how many grams I can plate if I have a 0.5 amp current running for 2 hours. So we're looking for grams here. What I would do when you have these type of questions, your first approach is to solve for Q, solve for coulombs, and then you do stitches. Okay, so you solve for coulombs, then you do stitches. So Q is equal to 0.5 amps. What do I have to do with that time? Convert it into seconds. So 2 hours, there's 3,600 seconds in every hour. So what is that, 72? Is that 7,200 seconds? All right, you all see how I did that? So I would get 0.5 times 7,200. We're not worried about the math, but that's in coulombs, right? So now you put it in stitch. So I take this coulombs. I have to first get out of coulombs. To do that, I'm going to use Faraday's constant, which is 96,500 coulombs is equal to 1 mole of electron. What's wrong, Megan?
I don't know how I'm going to remember all this for the test. All mixed together. Yeah.
Is none of this going to be separated, or are you just going to like throw in 8,000 different questions from different units?
Throw them all in together. Because that's how the real AP test is.
I'm just going to quit school.
Huh?
I'm going to quit school.
I'm going to zone
I'll join so
Now I have to get from moles electrons to regular moles. So how do I do that? Alright, I look at an equation. So how many moles of electrons for how many moles of copper do I have? 2 for 1. So 2 moles of electrons for every 1 mole of copper. And if I'm mole of copper, hard part's out of the way. Can we get in the grams of copper? Yeah. So we have a mole of copper is equal to 63.55 grams of copper. And you would chug it out from there. Remember, on multiple choice, you do not have to do this math in your head. They'll have an answer that's set up like this. Okay? And that is Electrochem in a nutshell.